Hello friends, welcome to this lecture on computer-aided power system analysis. In the last lecture, we have started the derivation of the admittance matrix corresponding to different types of symmetrical and unsymmetrical fault. In the last lecture, we have looked into 3 different types of fault. One is LG and then LL and then LLG. Today, we will be looking into the other remaining 2 types of faults, that is LLL and LLG. So, let us start. Fault analysis. So, what we are doing is, so now we are considering LLL fault. So, this LLL fault is we have B, C, A, B, C, and we have so this is an LLL fault. Please note that. So, this is IAF, IBF, ICF, and these are all ZF. So, let us see that these are all given as ZF. So, now let us say that this point is N neutral points. So, then therefore, applying KCL at N, applying KCL at point N, we got IAF plus IBF, ICF is equal to 0. So, we get VA minus VN plus VB minus VN by ZF is equal to 0. So, then therefore, 1 by ZF into VA plus VB plus VC is equal to 3 by ZF into Vn, or in other words, Vn is nothing but the average of Va plus Vb plus Vc. So, then therefore, IAF would be 1 by ZF into Va minus 1 by 3 Va plus Vb plus Vc. So, that is equal to 2 Va minus Vb minus Vc by 3 ZF. Similarly, IBF would be 1 by ZF into Vb minus 1 by 3 plus Vc. It would be minus Va plus 2 Vb minus C by 3 ZF, and ICF is 1 by ZF to Vc minus 1 by 3 Vb C. So, it is 1 by, so it is minus VA minus VB plus 2 VC by 3 ZF. So then therefore, if I put all of them in a matrix form, it would be YF by 3, 2, minus 1, minus 1, so 1, 2, minus 1, minus 1, minus 1, 2, VA plus, VB, VC. Where 1 by YF is equal to 1 by ZF. So then therefore, this quantity is nothing but Y fault. So this quantity is Y fault, right. So this is Y fault, this is easier. So now let us look at LLLG fault. So now we are looking at LLLG fault. So L so what we have is and then we have so what we will have is, so if A, B, C all are ZF, 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 ZZ, ICF, IBF, IF. Again, as usual, we take this point to be, let us say, N. This is N. This point is N. So applying KCL at point N, applying KCL at point N, what we can write down? We can write down that and VA write down VA minus VN by ZF plus VB plus VN ZF plus VC plus VN by ZF is equal to Vn by Zg. So then therefore we have 1 by ZF into VA plus VB plus VC is equal to 3 by ZF plus 1 by Zg into Vn. So it is 3G 3Zg plus ZF by Zg ZF into Vn. So then therefore Vn would be simply Zc by 3Zg plus ZF into VA plus VB plus VC So, this would be the Vn. So, then therefore, IAF would be 1 by ZF VA minus Vn, and minus Vn is Zg by 3 Zg plus ZF into VA plus VB plus VC. So, now what we have? We have, so then therefore IAF, so then therefore 1 by ZF into 3 Zg plus ZF into VA into 3 Zg plus ZF into VA minus ZgVA minus ZgVB minus ZgVC into 3 Zg plus ZF. So, then therefore IAF would be 1 by ZF 2 Zg plus ZF into VA minus ZgVB minus ZcVC by 3 Zg plus ZF. Now, suppose we define, now let y0 is given by 1 by 3 Zg plus ZF and yf is given by 1 by ZF. So, then therefore y then y0 plus 2yf, what I get? Y0 is 3 Zg plus ZF plus 2yf is 2 by yf. So, that would be yf plus 6 Zg plus sorry should be ZF. So, 6 Zg plus 2 ZF by ZF into 3 Zg plus ZF. So, this can be written as 3 into 2 Zg plus ZF by ZF into 3 Zg plus ZF. So, that you can write. So, this is equation 1, and y0 minus yf. y0 minus yf would be 1 by 3 zg plus zf minus 1 by zf zf minus 3 zg minus zf by zf into 3 zg plus zf. It is minus 3 zg by zf into 3 zg by zf. So then therefore now from equation 1, IAF is equal to 2zg plus zf into VA, 2zg plus zf by zf into 3zg plus zf, 3zg plus zf into VA minus zgVB by zf, 3zg plus zf minus zgVC by zf to 3zg plus zf. Now here if we do utilize these two relations, it can be written as this is y0 by 2yf. So it is essentially y0 plus 2yf by 3 into VA. This is essentially y0 plus 2yf by 3 into VA, and this is plus y0 minus yf by 3 VB plus y0 minus yf by 3 VC. Let just for the sake, let's say this is equation 2, this is equation 3. So we can write down utilizing equation 2 and 3. So this is the expression of IAF. So let's say this is equation 4. So similarly, if we look at the expression of IBF, it will be 1 by ZF into VB minus by 3ZG plus ZF into VA plus VB plus VC. So if we repeat all these derivations as compared as we have done here, so you will find that it is nothing but 1 by ZF into, it is minus ZGVA minus ZGVA plus 2 ZG plus ZF into VB minus ZG VC minus ZG VC divided by 3ZG plus ZF. So it would be also similarly, it will turn out to be y0 minus yf by 3 VA plus y0 plus 2yf by 3 VB plus y0 minus yf by 3 VC. So this is equation 5. Similarly, for the expression ICF would be 1 by ZF Vc minus Zg by 3 Zg plus ZF into Va plus Vb plus Vc. So it would be ICF would be 1 by ZF minus ZGVA minus ZGVB plus 2ZG plus ZF VC by 3ZG plus ZF by 3ZG plus ZF. So in other words, ICF is essentially y0 minus yf by 3 into Va plus y0 minus yf by 3 Vb plus y0 plus 2yf by 3 Vc. So equation 4, 5. So from equation 4, 5, 6 we can write down. So from equation 4, 5, 6 4, 5 and 6. What we can write down? We can IAF, IBF, ICF, so it will be 1 by 3 so it is y0 plus 2yf, y0 minus yf, y0 minus yf, it is y0 minus yf, y0 plus 2yf, y0 minus yf, this is y0 minus yf, y0 minus yf, y0 plus 2yf, and this is into Va, Vb, Vc. So therefore this is the Y fault matrix. So this is the Y fault matrix. So then therefore if we know that what is the fault impedance at any phase and what is the ground fault impedance, we can simply find out the Y fault matrix. So then what does it mean? So it means that for any fault either LG or LL or LLLG, LLLL or LLLG, any fault can be represented by a 3 cross 3 fault admittance matrix. So, this is Y fault. In short, when you would be writing as in Y fault, let us denote as Y fault as let us say Y, let us say P F A B C. So, here what does this P stands for? P stands for here essentially let. So, now let Y fault be denoted as we should write that Y fault be denoted as Y P F A B C. So, what are the different quantities which they signify? P stands for the bus. P stands for the bus at which the fault takes place. F stands for fault, stands for the stands for the bus at which the fault takes place, stands for fault. And ABC is denotes that it is a 3 cross 3 matrix involving all phases ABC. All phases A, B and C. So, this is the notation. So, then therefore, now suppose there is a bus . So, this is phase A, phase B, phase C, and this is bus P, and let us say there is some fault, and so then therefore, if there is some fault, we can simply represent it as some fault which is, let us say, Y P F A B C. So, then this fault can be represented as Y P F A B C. Now, if these voltages are V P F A, these voltages are V P F B, and these voltages are V P F C. So, why these voltages are V P F, let us say L stands for fault voltage at bus P corresponding to phase L, where L is equal to A, B or C. right. So, then therefore, VPFA stands for the fault voltage at bus P corresponding to phase A. This is fault voltage at bus P corresponding to phase B, and fault voltage at bus C corresponding to phase C. And let us say these currents are denoted as IPFA, this is let us say IPFB, and let us say this is IPFC, right. So, similarly IPF, and let us say these currents are IPFA, IPFB and IPFC, where IPFL is the fault current at bus P corresponding to phase L, where L is again A, B, C. So, now, so then this is the case. So, now what we have? So, I have bus P, it has got 3 phases A, B, C, and it can have any voltage, it can have any type of fault it can occur, let us say LG or LL or LLG or whatever. So, then therefore, as we have already seen that any fault can be represented by an fault admittance matrix, which is written as YPF ABC, and because of this YPF ABC, so then therefore, these bus voltages are now let us say fault voltages VPFA, VPFB and VPFC, and as well as the current flowing to the fault are given by IPFA, IPFB and IPFC, right. So, then therefore, this is the representation of the fault, and this representation is perfectly general representation, because this representation takes into account any type of fault. Now, with this representation, we are now in a position to analyze the effect of the fault occurring at any bus of any large scale power system. This issue would be taken in the next lecture. Thank you.